Okay, so we're going to start out the new semester with a 6.1 to 6.4 review. It's been a while since we've seen these types of questions, so I really want to take some time to answer any questions that you may have and also to review the concepts that were previously learned so that, you're ready for our quiz on Friday. And that quiz will be cumulative for the chapter 6, and then we'll move on to chapter 7. Okay, so for the first one, it's just about remembering our rules of exponents. There are a couple things that we have to remember. What's one thing? What happens to the x to the 0 power?
1.
That's a 1. Okay? So we'll make that a 1. We already know that that's a 1. Here we go. Okay, so as was previously said, that x is 0 becomes a 1. So we'll make that a 1. So that's just 2 times 1. What else do we have to remember? Simplify. Yeah. Yeah, exactly. So we're going to take this negative exponent, we're going to move it to the numerator from the denominator, and it becomes positive. So really what we're looking at is 2. That's just 2 times 1. And then we have an x squared at the top. We have a 4 in the denominator still, and we have a y to the 4th. And all of that is squared. And we have a couple options. We can reduce a fraction if we want to, just to 1/2, right? Or we can wait till later and just take everything to the second power. So what will I end up with if I choose to simplify later? And I take 2 to the second power, 4, and then x to the second power. Remember? X to the 4th. Remember that when you take a power and you raise it to a power, you multiply the two of them. And then what will I end up with in the denominator? 16. Y to the 8th. Perfect. So now I can reduce this, right? What's 4 over 16 reduced to? Yeah, 1/4. So really, I just have x to the 4th over y to the 8th. Okay, this is actually a quiz question for that group quiz that we did. Do you have any questions about that? Oh, there's a 4 on the bottom here. Yes. Do you have any questions about that? Yeah. It doesn't just go away. All right. What do you think about that table? Is that exponential? And if so, why? If not, why not? Do you remember? First thing that we need to remember about exponential functions and looking at tables is the x values are always going to increase by a constant amount. So in this case, they're always going to increase by 1 every time, right? So 1, 2, 3. Why? Because oftentimes when we graph exponential functions, we look in terms of years. The first year, the second year, the third year, the fourth year, etc. Remember that? Now, the y's are different. The y's change not just by adding a constant. How do they change? Do you remember? By multiplying by something. Whether that's a fraction, so you're technically dividing, or that's a number greater than 1. So what is that constant ratio that they're being multiplied by? 3, yeah. So each of these consecutive terms, consecutive meaning one right after the other, is being multiplied by 3. So that is exponential growth. It would be decay if we were multiplying it by a fraction. Do you have any questions about those two concepts? Good job. So for this question, which will most likely be a bonus question, I want you to first of all, before we get into the graphing part of it, identify the transformations, because you do need to be able to identify the transformations. I might give you something like this, not have you graph it, but tell me all the transformations that it's undergoing. So what does the 6 do? It stretches it. It's a vertical stretch by a factor of 6. So the very first thing that we need to note is the vertical stretch. So if I were to give you this on a quiz, you would say this is a vertical stretch by a factor of 6. Okay. What does the minus 4 do? Right, yeah. Moves it to the right 4 units. So this is a horizontal translation. Translation meaning movement. Four units right. Excellent. What does a minus 1 do? Moves it down 1. So this is a vertical translation. Again, vertical meaning up and down, translation meaning movement. Vertical translation. One unit down. If I give you something like this on your quiz and I ask you to identify the different types of transformations, can you do it? If I had a negative, what would that do? It would reflect it, right. If I had a fraction, if I had a 1/3 instead of a 6, what would that do? It would be compression, right. As far as left to right, right to left, that's good to know and to give you an idea, but you don't have to know it. Now, as far as what you will see on the test, I will most likely have you graph something like just 6 times 2 to the x. And that's really where you want to start to graph something like this anyway, is think about that. Now that's not the parent function. What is the parent function? Yeah, so the parent doesn't have anything attached to it. It's just the 2 to the x. Right. So far, if I ask you on a quiz, tell me what the transformations are, identify the parent, and you do that. Okay. Now, I'm going to ask you to identify the vertex. Do you remember what the vertex is? Not the vertex, the y-intercept, sorry. You know what the y-intercept is? 0, 6. 0, 6. How did you know that? Y-intercept is always a number in front. Okay? So when you're studying for this, make sure you remember that if I ask you on a quiz, okay, tell me what the parent is, describe the transformation, identify the y-intercept, you'll be able to say that my intercept is 0, 6. Now if you don't remember that rule, then just plug in 0 for x and solve for the intercept yourself, right? Do you have any questions about identifying the intercept, identifying the parent function, and describing the transformations for an exponential function? Okay. Go ahead and write that down. I'll erase it, and then we'll start graphing it. Okay, so I'm going to go ahead and erase this before I start the actual graph. There we go. Okay, so I said in order to graph something like this that's translated, you have to start with the 6 times 2 to the x. Don't worry about any of the translations yet. So this is how you want to start, and this was a quiz question. You want to start with the intercept, and we said the intercept, the y-intercept is 0, 6. Do you remember what we do to get to the next one to the right? So let's, well, you can. You can always do that. What's a quick way? Do you remember the quick way? No. Multiply by that constant ratio. What do you think the constant ratio is? Nope. 2. So what would our next point be? 112. Yeah. What would the next point be? 224. Okay. And do you remember? How do we go backwards? If I wanted to go to -1. Yeah, divide by 2. So if I wanted to go 6 divided by 2, I get -1, 3, right? And you can see, if you put -1, right, you will get 3 out. And then -2, 3/2. And maybe 1 more. When in doubt, just plug it in, if you don't remember that trick. This is just a quick way to do it. Again, really what I want you to get out of a problem like this for the actual quiz is to identify the transformations and the intercept. Actually, graphing it is a bonus. Okay. Now, how will these translations affect the x's? You're going to add 4 to each of them, right? So 0 becomes a +4, 1 becomes a what? A 5, 2 becomes 6, -1 becomes, well, when you add 4 to -1, you get 3, right? And then -2 becomes 2. Right. How will our y's change? Subtract 1 from each of our y's. So 6 minus 1, 5. What's my next y? 11. Next. Yeah. And then, of course, just subtract 1 from that and you get 1. Alright. Now you can actually start graphing. This one, this first T-chart, you will be expected to know that for regular credit. Can you graph something like this without the left, right, up, down? The second one, extra credit. Okay? And then so we're going to graph just the points on this second graph here. So 4, 5. And then 5, 11. 623, I won't graph that. Remember, you don't have to graph every point on here. Just enough to give you that shape. 3, 2. 2, 1/2. And actually what's going to end up happening is it's going to go like this. Why do you think it goes like this instead of stopping at that x-axis? Yeah, because this, right? That affects what? Does that affect the domain or range, do you think? Yeah, this affects my range, right? And if you wanted to graph a few more points and see exactly where your asymptote is going to be, remember the asymptote is that sort of invisible line, horizontal line that we don't cross. You can always plug in a few more points. You could plug in 1/2 or whatever. But this will tell you essentially what your range is. Don't go past -1. If there was a -2, don't go past -2. Does that make sense? Okay. So, with that being said, what is your domain? All real. Right. How'd you know it was all real? Yeah, it goes both directions, exactly. You have arrowheads on both directions, so it's all real. What's your range? What? Right. Y is greater than -1. -1 all the way up to positive infinity. Okay, I know that was really tough. Do you have any questions about graphing this? Again, what is expected of you for this quiz? Identify the parent, identify the y-intercept, identify the transformations, be able to graph something like 6 times 2 to the x. Alright? And then any more is going to be bonus. Questions before I move on? Alright, take, 3 minutes. Okay, continuing back with this, number 16. We are continuing. Thank you. Is number 16, is that an exponential growth or decay?
Growth.
Growth.
Wait, I mean decay.
Okay, how do you know it's decay? What's less than 1? 3/5. Good job, Bob. 3/5. So this is a decay because we see that 3/5 is in between 0 and 1. Remember that anytime we have a b value that's in between 0 and 1, that makes it a decay. So our general form is a b to the x. Now for exponential growth and decay, we have a little bit more, it's a little bit more complicated, but not too much more. So for decay, it's y equals a times, do you remember what goes on the inside of the parentheses? 1 minus r, I will give this to you on the quiz, okay? 1 minus r to the t, right? And then that's decay. What's different with growth? 1 plus r to the t, that's growth. I will give you those, so you don't have to worry about memorizing it. Okay, if I ask for the percent rate of change, do you remember how to do that? That's all right. Well, to find the percent rate of change, all you do is you take the 3/5, you set that equal to 1 minus r, and solve for r. So you're going to take 1 minus r, set that equal to 3/5, and solve. So subtract 1 on either side, you get negative r equals negative 2/5. R equals 2/5, Abby. So that expressed as a percent is 40%. Do you have any questions? No questions. Right. Here is a tentative schedule for the next few days. I think I'm actually gone on one of those days. I should really check that out. I have some sort of, I think, in-service on the 3rd, 2nd or 3rd, maybe the 3rd. But we will be doing 6-5 today, 6-5 tomorrow, 6-6 on Thursday or Wednesday, then review, and then the quiz test. We will be starting our notes. Alright, so this is just an introduction to more properties of exponents, but solving now. We're going to set two bases. Remember, you have your base and you have your exponent. So that's your base, and this is your exponent. We're actually going to look at solving something like this. Well, this is pretty simple because we know x has to be what? 4. Right. So, mixed in there, we'll have some operations and things where we're going to have to actually solve and do a little bit more work. And sometimes they're not going to both be 2s. We're going to have to express it as the same base to fully solve. So really, the first thing that we have to look at is what are exponential equations. Those are just equations. Remember, equations have equal signs in which variable expressions occur as exponents. So our expressions are x and 4, we set them equal to each other. Questions on that? The hard part comes tomorrow. Not really today. We're just going to ease into it today. Next page. Alright, so core concept, property of equality for exponents. We have a property of equality just like we have for equations here, the regular linear equations that we looked at. Now we're looking at equations with exponents. It says that 2 powers of the same positive base b, where b cannot equal 1, are equal if and only if their exponents are equal. When you take geometry, you'll look at the if and only if stuff and why we talk about things that way, but For now, you really just need to understand the basic rule. Basic rule is if 2 to the x equals 2 to the fifth, then x equals 5. So in other words, we can set their exponents equal if and only if their bases are equal. So if I have 2's in both bases, if I do, then I can set their exponents equal. I can say x equals 5. Or if I have an x plus 1, I can say x plus 1 equals 5 and then solve for x. And you should be able to check, plug x back in, and you should get two bases with exponents that end up being the exact same. Does that make sense? So that's essentially what we're going to be doing. It says that if b is greater than 0 and b cannot equal 1, then b to the x equals b to the y, if and only if x equals y. So they're just setting the things equal. Again, if we have the same base. We can't just do that willy-nilly. We have to have the same base. Okay, we're going to look at a couple examples. What did you get for the first one? What does x equal? 4. Right. We know that we have the same basis. Because we have the same basis, we can set their exponents equal. I will say that over and over again because right now it's easy because we see examples with the same base. You will have something like, let's say, 3 to the x plus 1 equals 9 to the fifth. You can't set those two things equal until you express 9 in terms of 3 to the second power. Does that make sense? So we're going to be doing that tomorrow. But as far as today, since we have the same base, we just set x plus 1 equal to 5 and solve. Subtract 1 on either side using our subtraction property of equality, and we get x equals 4. And you could check, plug in 4. 4 plus 1 is 5, and we end up with 3 to the fifth equals 3 to the fifth. Okay. What did you end up with on B? 2. Right. So you set 2x minus 3. What did you set that equal to? 1. Right. There's an implied 1 there. 6, if it doesn't have anything in the subscript here, or superscript, then you know it's a 1. Not a 0, because anything with the 0 power is 1, right? So we set that equal to 1. Solve for x, add 3 to both sides. We get 2x equals 4, x equals 2. 2 times 2 is 4. 4 minus 3 is 1. So 6 equals 6. Okay, any questions about A or B? Amongst you? Okay. One more example. Okay. Example C. What will I set equal in example C? 3, what will I set equal in example C? Oh, maybe you should be on your phone. 3x equal to what? 2x plus 3. Thank you. Solve for x. Subtract 2x. Subtract 2x. X equals 3. Again, you can check. 10 times 3. 10 to the 3 times 3 is 10 to the 9. For the one on the left side. And on the right side, 10 raised to 2 times 3 plus 3 is 10 to the 6th plus 3, which is 10 to the 9th as well. Any questions? Right. Don't make phones a problem, guys. Okay. As far as what I want you to do tonight, well, actually, give those a try. At least one of them.